Hello, my name is Thomas King. My partner and I, Mia Roettger, have conducted a research project for Pope John Paul II. Our project tests the reaction time of Alka Seltzer cold and flu tablets in water. The purpose of this experiment is to find out how the temperature of water affects the dissolving time of Alka Seltzer tablet. The hypothesis that we assumed is that if the water temperature is higher, then the reaction will happen faster, and if the water temperature is lower, then the reaction will last longer. We've seen this problem like this in our day-to-day life, like if you leave a drink in a car for 20 minutes and it's hot outside. The drink will get hot because the heat is making the particles move faster. But if it is cold outside, then the drink will remain cold because there's no energy causing the particles to move. In relation to this experiment, we've assumed that the heat of the water would then cause the particles to react quicker with the tablets, thus causing the reaction to occur more quickly than if the temperature was low, causing slow particle collisions. For this experiment, we needed 15 Alka-Seltzer tablets. Distilled water was needed to make the Alka-Seltzer dissolve, a timer to record the reaction times, a computer to log all of our data on. We used ice and a hot plate to affect the temperature of our water for these reactions. A thermometer was used to record temperature of the water before each trial. A lab quest to plug into the computer to record our data. A 150 milliliter beaker, which we used to record how much water we had, and for the reaction to happen in it. A separate container used for heating and cooling so the temperature of the glass would not affect the reaction of the tablets. We cooled the water to 10 degrees Celsius and heated it to 25 degrees Celsius for our different reaction times. We used 118.3 milliliters of water for our different reaction times. 118.3 was the chosen amount because the tablets are supposed to dissolve in 4 ounces of water. And when converted to milliliters, this amount is about 18.3 milliliters. For heating and cooling of the distilled water, we poured the water into different beakers to make sure our data was accurate. We then recorded the reaction times and logged them onto the computer. We also repeated these steps with 50 degrees Celsius, 75 degrees Celsius, and 100 degrees Celsius. In addition, any important reminder is to maintain the mass of the tablets for each trial and temperatures, so that the data remains consistent. As shown by the data, the temperature greatly affected the rate of the reaction time of the Alka-Seltzer tablets. At 10 degrees, the reaction time was the longest, at an average of 2 minutes and 50 seconds. However, at the hottest temperature of 100 degrees, the reaction occurred very quickly at an average of 0.410 minutes. As mentioned previously, this makes sense due to the speed of particles at the different temperatures, being much slower when the temperature is low and much quicker as the temperature rises. In the graph shown, the x-axis represents temperature and the y-axis represents the time of reaction. Varying the temperatures of 10 degrees to 100 degrees Celsius, the reactions vary dramatically from 0.410 minutes to 2 minutes and 50 seconds. All in all, the standard deviation was not consistent throughout the experiment, as the time of the reaction became much quicker. As mentioned previously, the purpose of this project was to obtain a full grasping of the effect that the temperature of the water would have on the length of the Alka-Seltzer's reaction. Initially, we said that if the temperature was higher, then the reaction will occur much quicker than if the temperature was cold. Our data proved our hypothesis correct. The reaction is affected by the temperature because of the speed of the particles when placed into the water. The kinetic energy that the particles gain as the temperature rises and the lack of which they have when the temperature is lower causes the different reaction times depending on the selected water temperature. This is proven by the data showing quicker reactions with higher temperatures. As the reactions occur, the ions split into separate ions by the end of the reaction. These products made are carbon dioxide gas, liquid water, and aqueous sodium citrate. While our data was consistent throughout the experiment, there were still errors present. The unknown amount of particles in each tablet is impossible to know exactly. This, however, does not affect the data greatly. In addition, and probably the most difficult, are the errors that come with timing of the reaction. This also goes hand in hand with the placement of the tablet into the water at the same time as the timer is begun. Lastly, misreading of the thermometer could have caused issues in addition to the contact with the oils on our skin. Lastly, here are the references that we used in aiding correct conduction of this experiment. Thank you.